Today we're looking at math lesson 14.1, fractions, relate fractions to area. We had a discussion here in the classroom that area is the measurement of the surface of something, of the covered surface. So we put it in square, remember, square inches, square feet, whatever. Let's read our I can statement together. You ready? I can use fractions to show that equal parts of a whole shape have the same area. Okay. Lindy's hamsters are Alvin, Betty, Coco, and Doug. Liddy puts up a wall to divide her hamster's playground into left and right halves. Then she puts up screens to divide each half of the playground into two halves. Now each hamster has a second space to play. Which hamster will get the largest play area? Raise your hand when you know which hamster got the largest play area. Raise your hand when you have an answer. Okay, I'm going to draw a stick. I hope that person has an answer. Avery. They're all the same amount. Thumb up if you would agree with her. Why could you tell they're all the same amount?
Because, like, if you put it together, it could all be like the same size.
Right. When she did her original line, she cut her diagram in half, right? So we know that each side of that is a half. And then she equally divided those halves. Now, one of them she drew a vertical line, and one she drew a horizontal line. And even though it doesn't look like it, each one of those sections is 1/4 of her original play area for her hamsters. Okay? So they are all going to get the same space. Okay, so if you're at home and you want to, you can redraw the hamster cage down in the gridded area. But really all you need to know is that all 4 hamsters get an equal space. Okay? Let's go on to the next page. Building understanding should be page 386. Davida draws lines to divide shapes A, B, and C. Which shapes are divided into equal areas? How can you show which shapes are divided into equal areas? So I want you to go ahead and circle the ones that you believe are divided into equal areas. Okay, here in the classroom, we're raising our hand if we think A is into equal spaces, equal shapes. Okay, how can we tell if they're equal shapes? How can we tell though? How could we actually pick it up and tell?
Like because they're the shape.
But doesn't, I could have drawn 3 triangles that way. Hey, I know, but how would you know? How could you prove it?
They're instead like equal spaces.
Could we cut them apart and lay them on top of each other and see that they fit on top of each other? If you circle B, raise your hand. How can B, can I fold that on the middle line there?
Wait.
Can I fold it on this line and they're going to like fold the bottom up to the top and they're going to match? No. Those would not be equal spaces. It is divided, but it's not equally divided. Okay, does that make sense? All right, how about C? How many of you thought C was equally divided? Again, could we fold it on our center line? And now that one fit over the other? Yes. Okay, so shapes A and C are correct. Please write that. A and C are divided equally. Okay, so together we determined that A and C are divided equally. And how we could find out was you could cut the shapes on the lines and lay the pieces on top of each other to see if they are all the same. So go ahead and stop your recording and work on that. Okay, we're moving on to number 2. Edgar draws lines to divide circles A and B. Each circle is the same size. Are the parts of circle A equal or unequal? Are the parts of circle A equal or unequal? Equal. So on the line, I want you to write equal. That answers our first question. And then put a semicolon. How do we know they're the same? What are some things we can do? Well, they're all the same shape and size, right? Each of these little parts are all the same shape and size. How can we tell if they're exact? We could what? Cut them apart and stack them. Okay, so how we know is they are all the same shape and size, and we could stack them to see if they match. Go ahead, stop your recording and get that. The part B of number 2 is, are all the parts of circle B equal or unequal? Thumbs up if you think equal, thumbs down if you think unequal. Circle B. They are unequal. So everybody should write unequal. Okay? And of course, then it wants us to explain, why are they unequal? What lets us know that they're unequal?
You can't stack it. You can't.
Some of the parts are small and some of the parts are large. Page 387. Raina divides a rectangle into parts. Are the parts of the rectangle the same shape? Are all the parts the same shape? No, they are not the same shape, are they? No. No. They are all different shapes. Do the parts of the rectangle have the same area? And how do you know? Do they cover the same area, Emily? Yes, they are. Each part has 6 unit squares. What fraction of the total area of the rectangle is shaded yellow? I want you to think about how many parts this rectangle is divided into. How many parts are there? How many equal parts? 4. So the yellow part is what fraction of that whole? No, there are 4 parts, and it is one of those 4 parts. So you would write 1/4, 1/4, semicolon. Then it says, how do you know?
Because there's 4 in all, and you're looking at the yellow.
Yeah. The yellow is 1 of 4 equal sized parts. Well, we're going on to the check your understanding. So please, if you're at home, go ahead and try and do the check your understanding, and then come back to the recording for your answers, to check your answers. Okay, neither. They are both 10 unit squares, so they are equal. Okay, we're going to the on your own on page 388. Garrick says that the shaded area is 1/3 of a whole because it's one of the 3 parts of all the same shape. Aiden says that the shaded area is not 1/3 of the whole because the 3 parts do not have the same area. Which student's reasoning is correct? Rhiannon, which student's reasoning is correct? Garrick or Aiden? Aiden is correct. Why is Aiden correct?
Because he says that it's not equal parts and they're not.
Okay. Aiden is correct. Not all the parts are equal. Number 4, cross out any shapes that have parts with unequal area. Cross out any shape that has parts with unequal area. Okay, we should have crossed out the triangle. Number 5, are parts of the rectangle equal and are the parts of the rectangle equal in area? Are they? How do we know that? Yes. Whoops. Each shape has an area of 4, oh my gosh, of 4 square units. What fraction of the rectangle is shaded blue? What fraction of the rectangle is shaded blue? 1/3. There are 3 parts, right? The kind of red part, the yellow part, and the blue part. So 1/3.